Welcome you all to our second class of real number. So, first let us have a revision. So, in last class we have discussed what is real number. It is the combination of both rational number as well as irrational number. Then we have discussed some properties of real number, and to be specific I have mentioned. So, when we are talking about properties of real number, but we are discussing the properties of to the point positive integers, that means the natural numbers. So, the first property was Euclid's division lemma, and we have used it to solve many questions, as well as then we have used it to find the HCF. But today we will discuss the second property, that is fundamental theorem of arithmetics. Just like the previous one, it is not a very new things, already all of you know about this. So, in short you call it prime factorization. So, from class 6 to class 9 many times you have calculated the prime factorization. So, fundamental theorem of arithmetics, the name is very big, but you can think it as the simple prime factorization. So, you have seen here 6 is equals to 2 into 3, 12 equals to 2 into 2 into 3, 14 equals to 2 into 7. So, all as the prime factorization, and this is fundamental theorem of arithmetics. And if I will go to the definition, it is every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factor occurs. So, one thing all of you know, it is prime factorization, but you may have doubts in 2 points. One is unique, one is order. So, unique means if I am prime factorizing 14, it is 2 into 7. So, this is the unique prime factorization, means you take any other composite number, if you will factorize that, you will not get 2 into 7. Already once you have get 2 into 7, that is for 14. So, any other composite number you will not get 2 into 7. So, let us take example of 12, it is 2 into 2 into 3. So, that is unique, means this is only for 12. From 1 to 1 crore you may get many numbers, you may prime factorize all the composite numbers, but in no case you will get 2 into 2 into 3. Now, I think just like your ID card, your unique means the prime factorization is unique, that belongs to that particular prime factorization of the composite number. And the next, the order means it is the sequencing means it is the arranging the numbers or organizing the numbers. So, it is given order in which the prime factor occurs, means here order is not taken importance. So, 2 into 7 is same as 7 into 2. So, 12 I am writing 2 into 2 into 3, you can write 3 into 2 into 2. So, means the way you are writing left to right or right to left, it is not important, because you know this is the commutative property in multiplication. So, now we will discuss example 5 of your ncert book. So, the question is, consider the number 4 raised to the power n, where n is a natural number. Check whether there is any value of n for which 4 raised to the power n ends with digit 0. If I will simplify the question, indirectly it is asking, is there any number n, means 4 raised to the power anything ends with 0. For example, 4 square is 16, 4 cube is 64. For it is asking 4 raised to the power any number you take, is it end with 0 or not. So, we will solve it. So, first thing, we know that all the multiples of 10 end with 0, means 10's multiple 20, 30, 40, 50, 80, 100 all end with 0. If I will opposite the sentence, reverse the sentence, a number to be end with 0, in the end there must be divisible by 10, and to be divisible by 10 it must be divisible by 2 and 5. So, it is a concept class 6 we have already discussed. So, a number to be divisible by 10, it must be divisible by 2 and 5, and for in the example you can check 10, 20, 40, 150, everywhere there is at least 1, 2 and 1, 5. So, we need 2 and 5, at least 1, 2, at least 1, 5. There may be more than 1, 2, more than 1, 5, no problem. For minimum we need 1 to 1, 5, and we will check it, that 4 raised to the power n, we will prime factorize it, and we will check is there the factors of 2 and 5. And when prime factorizing 4 raised to the power n, 4 is prime factorized as 2 square, then raised to the power n. So, it is 2 raised to the power 2n. So, as there is only the prime factor is 2, the 5 is not as a prime factor here. So, 4 raised to the power n does not end with 0 in the n. Now, we will discuss some more application of fundamental theorem of arithmetic, and one important more application is finding HCF and LCM. So, HCF is highest common factor, that means, and LCM is lowest common multiple. So, earlier we are calculating all the factors of 12 and then calculating all the factors of 20, then calculating all the common factors, means which is in 12 as well as in 20, that is 1, 2, 4. Then among the common factors, which is the highest, that is the 4. After that we discussed another method which is very easy and we used it, that is the prime factorization method. So, here we prime factorized 12, we prime factorized 40, and we take common factors. In 12 and 40, 1 to 1 2 means 2 2's we have taken common. So, the HCF is 22 to 4. So, similarly, you can take the example of 60 and 90. So, 60 it is prime factorized, 90 it is prime factorized in both the case, in both the lines. So, 2 is common. So, I have taken 1 2, then 2 is in 60, but there is no 2 is 90. So, 2 is excluded, then 3 is common in both 60 and 90. So, 3 is taken common, then 5 is 16 and in 90. So, 5 is taken common. So, the HCF is 30. So, now we will calculate the HCF of 12 and 40 in the same manner, little bit in a easier way. For example, 12 previously we were writing 2 into 2 into 3, now we will write it in the exponential form, that is 2 square raised into 3 to the power 1. Similarly, 40 we will write 8 into 5, now we will write 2 cube into 5, here little bit there is mistake, this is not 8, this is 5 raised to the power n. So, we will check what will be HCF, and in previous case among 4 and 8, so we are taking 4 as common. Now, 4 is 2 square, 8 is 2 cube. So, what will be taken common? 4 means 2 square. So, here you can observe what we are taking common, which is common we are taking that in HCF, but the least power is taken. So, 2 square 4. Similarly, in 60 and 90 it is prime factorized and written, you can check 2 2 both in 60 and 90. So, I will take 2 along with the exponent, that is raised to the power 1. Then 3 is present in both of them. So, I will take 3 as common, but the least power, that is 3 raised to the power 1. Similarly, 5 is in both of them. So, I will take 5 raised to the power 1. So, here the HCF is 30. To summarize all the steps I have discussed. So, first we will prime factorize the numbers and we will write along with the exponents. Then when calculating HCF, we will first check which factors are common, then we will take the factors which are common along with the least exponent or least power, then we will multiply them to get the HCF. Just for here reference purpose, I have written HCF. HCF means highest common factor. So, here we are calculating factor. So, factor means it is a lesser number. So, lesser means least or lowest power will be taken considered. Now, we will come to LCM, and it is contradictory to HCF, means it is somehow opposite of HCF. So, we are taking all the factors, but in HCF we are taking the common factors, but in LCM when we are calculating we are taking all the factors, but with the highest power. There we are taking common factors, in LCM we are taking all the factors. In HCF we are taking the least power, in LCM we are taking the higher power. So, LCM means lowest common multiple. So, it is one type of multiple. So, multiple is greater than the number. So, greater means higher. So, now I think you are able to differentiate the calculation of HCF and LCM. In HCF you will write the prime factors, in LCM you will write the prime factors, but in HCF you will write the common factors, in LCM you will write all the factors. HCF factor means least power will be considered, in LCM multiples means higher power will be considered. So, now here we will discuss some example. So, 12 it is written 2 square into 3. So, 10 2 into 5. So, LCM I will take all the factors. So here 2 I will take, but which power? Now more power, so 2 square. Then 3, with 3 only one is there, so I will take only 3. Then 5. So we will take, sir, why these 2 I missed? I have encircled 2, 3, 5, but these 2 I have not encircled. Why? Now because this is common. So if this is taken common, already once taken, so twice 2 will be not taken, means all the factors will be taken once along with the higher powers. So next example, that is the 30 and 45. 30 2 3 into 5, 45 3 square into 5. So what are the factors? 2 3 5. So first I will write all the factors 2 3 5, then exponent I will think. So 2, what is the highest? 1. 3, what is the highest? 2. 5, what is the highest? 1. So another example, 18 15 30 20 75 14. I have taken a very long example so that your concepts will be clear. So 18, all are the prime factorized. So I will check what are the prime factors. 2 3 3 5 2 3 5 2 5 3 5 2 7. So here the prime factors are 2 3 5 7. So what you will write? You will write 2 into 3 into 5 into 7. Then I will check what is the highest power. So here 2 I can check, I have encircled, the highest power is square, 2 square. Then 3 it is also square, then 5 it is also square, 7 it is only 7. So I will multiply square, 2 square, 3 square, 5 square, 7. So the LCM is 6300. So all the points in the right side I have mentioned, you can just go through it. You have to write all the factors but only once. No factor will be repeated twice. Along with the factors which are written, their higher exponent will be written. And here there is a formula between HCF, LCM and the two numbers. So here you can see I have written there are 4 variables, number 1, number 2, HCF of the numbers and LCM of the numbers, and the formula is HCF into LCM equals to number 1 into number 2. In question, out of these 4 variables, any 3 will be given. That may be number 1, that may be number 2, that may be HCF, that may be LCM. Out of these 4, 3 will be given and 1 will be asking. So here there is one example. Here HCF is given, LCM is given, one number is given, we have to find the another number. So according to the formula, your HCF into LCM equals to first number into second number. So here HCF is given 2, LCM is given 12, 2 into 12 equals to 4 into second number. So second number equals to, it is 24 divided by 4, we will get 6. So this is all. Thank you. In the next class we will discuss irrational number.